Okay. And we just have to double check, make sure it is actually recording. So it is. There we go. All right. Okay, so this is the last lecture, the last day of instruction of the entire semester. That applies to all classes, all Monday, Wednesday classes. This is the last day of lectures. Are there any questions that you guys want to ask? Because I want to address any questions that you have at this point. No particular questions? Okay. And I can tell right away, well, not right away, but I can tell from talking to some of you, some of you actually have an app that is publishable, or it is useful enough that you can actually distribute it to people that you think they can use the app. So I strongly recommend that you continue to work on your project, after the class, because you might find it actually useful. Any other feedback you guys have about app writing?
I don't think this is a personal preference. I'm just not a fan of the code blocks themselves.
Okay, using the blocks to write code?
Yeah, I think that kind of slow going at times.
Mm-hmm.
I mean, I like the convenience of being able to go back and forth between the arranging kind of stuff, the components on screen, and then blocks. But when it came to stuff, I like being able to sort of like, just if I can type something, it'd be quicker than having to drag and drop and rearrange stuff. I mean, it makes sense logically.
Mm-hmm.
That way I know exactly what things are going to react to certain things. I know that this is a, I didn't like having to have all of my procedures on one thing. I wanted to be able to hide them all essentially, and then refer to them universally.
Okay, so I think that's a really fair assessment. App Inventor using blocks, to write code is cumbersome. Most of the time, not just some of the times, but most of the time. I'm a coder myself. I do all of my programming using VI, which is a really primitive, text editor. And I do find it, kind of really cumbersome to write code using the blocks. However, the Java way of doing app writing is really a lot more involved when it comes to knowing what pieces you need to know and how to connect those pieces. So if you want to prototype something and just want to throw something together, I think it's really hard to beat App Inventor. But your point is taken. I understand what you mean. When you say, okay, the blocks are kind of inconvenient because you cannot type. You have to drag and drop. You have to rely on your pointing device pretty much all the time.
Once you get really big and complex, it takes a lot more navigating to find the function you need to use or where you need to be in your code, as opposed to just being able to Control F a text document or something like that. To be able to search for the elements you need.
Yes, you certainly do not have an ability to search for something within the App Inventor. So, a part of that has to do with how you structure your code as well. I mean, if you structure your code well, it can alleviate a little bit of how frequently do you have to navigate and search for what you need. But I do understand that most of us will end up with like 20, 30 subroutines for one particular screen, and it is clear it's almost impossible to find that unless you collapse all the blocks. But once you collapse all the blocks, then you cannot actually see into the detail of the blocks unless you expand it. And then when you expand it, then you cannot see the other blocks anymore because they're all kind of too close together. So there are definitely organizational issues with graphical programming approaches. But I think in this class, it's still a slight advantage to use App Inventor because cisp362 is a co-requisite of this class, not a prerequisite of this class. So this really helps to get rid of the syntax issue. If it doesn't plug in or doesn't snap together, they don't belong together. So that means people don't have to actually deal with the syntax, where in Java you have to deal with the syntax issue, like missing a semicolon here, it doesn't compile anymore. So there are multiple issues to deal with in Java. But your point is well taken. I understand that part, completely. Okay, any other feedback? Yeah, go ahead.
I don't like the fact that you can't do stuff dynamically. So
Okay.
you can't add about it, take off about it, and add to, make a bigger list. Or
Yeah, you cannot instantiate. You cannot say, okay, I have one of these things, make me 5 of those, and in addition to this one, you cannot clone.
Yeah.
Not using the code to clone. You have to basically make all of those things, and then you have to hide the 4 to show only the 1, and then it's cumbersome. It's definitely lacking that ability.
yeah.
Go ahead.
Oh, I was just going to say that I think that for an initial prototype, it's very good to be able to get a proof of concept
Yep.
kind of thing. But if a person says, yeah, that's good, go with it, and they want to be able to have it adapted to different devices,
Yep.
then App Inventor, you have to recreate it in Android Studio to be able to have it available to those different APIs or different devices and stuff. So it's good as an introductory, to be able to say, yes, we can do this.
Right.
It's just unfortunate that it doesn't translate well or talk to Android Studio to be able to get you that next level.
That's an interesting point. I have not thought about that. The restrictions of App Inventor is so much that the code that it does crank out, if it does crank out code for Android Studio, it's only going to work for really early versions of Android, because it does. You can see how archaic it looks like when you use App Inventor, that the app doesn't look like a new app, a new type of app. So even if it does crank out Java code, it's not going to be modern looking, and I think that's partially why it doesn't even bother to crank out that code.
Right, but it is good for prototyping. Like I say, you want to show a proof of concept.
Yep.
If the person just has an idea and needs to see, visually, can this work?
Yep.
I mean, that's where I would most likely use the App Inventor first. To be able to quickly, within a week or so, be able to give somebody something that they can look at and say, okay, you got my idea. Now let's go further.
Yep. And for those of you who want to just find out what else you can do with App Inventor, I strongly recommend going to the gallery. If you have not been to the gallery, which is actually up here, once you get into App Inventor, is one of the items on the top. If you go to the gallery, you can find projects that other people have done using App Inventor, and you can see that some people really push it. They really push what the envelope of what you can do given the limitations and the restrictions of App Inventor. It depends on the purpose of your app as well. I mean, some apps do not really need to be dynamic. They don't need to create stuff dynamically. It depends on what type of app you're working with. Games, in general, I think unless the game itself is doesn't have a lot of graphical element, App Inventor is not really the best environment to write mobile games. Last time I taught cisp362, which is the next class, using Java. At the time, Android Studio was in alpha stage or maybe in beta stage, and we were still using Eclipse, which is another IDE or integrated development environment. It took us a long time, even just to replicate some of the stuff that we did in mid-semester in this class. It took us a long time just to get to that point, because the code that you have to write in Java is actually significantly more complex and more pieces that you have to put together just to get, let's say, list boxes to work. So there's definitely that part of Java programming that we are completely avoiding in this class. Okay.
Yeah, because I think his name is Derek Vanis. He has a video on YouTube where he talks about taking an app that he built in App Inventor and translating it into Android Studio, and it's literally just the code is step by step to be able to create objects and being able to. The easiest part about it was bringing over a WAV file and a PNG file for his graphics and sound, but everything else had to be created
Yep.
step by step.
Yep, that's definitely true. Now, some of you maybe, if you unzip an AIA file, you can actually see how the AIA file represent your blocks. So in theory, somebody can actually take a look at the AIA file, figure out what logic is represented by the blocks, and actually convert that mechanically into Java code. But it's not going to be very helpful because that Java code is going to be mechanically generated, which means it's all just going to be, it's not going to be easy to read for one thing, it's not going to be efficient, and it's also going to be locked into a particular way of doing programming. So using that basis of code, you really cannot get too far with it without making some major modifications anyway. So you might as well just start from scratch using Android Studio and get the rest up and running. Very good. And we already talked about how to use a JavaScript in this class to help you enhance what you can do with App Inventor. So I think that one is already demonstrated, which is the JS project that we worked on Monday. So this is one easy way, well, relatively easy way. It's convoluted in a way because you're abusing the web viewer to run JavaScript so that you can actually have some real program going on in the back end. But it is still an interesting way to get things going. It's not probably what you want, as a, to make an app more flexible, but it does, extend, the time or extend what App Inventor can do significantly, because a lot of text processing and stuff that you already know how to do in JavaScript, just leave it in a web viewer, and then you just use App Inventor to control the front end to display stuff and to have the buttons and whatnot. So there are certain things you can do to kind of extend what you can do with App Inventor, but there are definitely limitations as well. All right. So with all of that's done, talked about, I'll just kind of quickly go over, the user interface and all the other stuff, just so that you have an inventory of, what we have talked about in this entire, semester, just so that we don't miss anything important. Okay. So what we'll do is we'll start with the user interface components. We talked about, buttons, definitely. We talked about date picker, list picker, time picker, right here. We talked about the text box, the slider. I didn't really talk about the password text box, which is kind of a text box. It doesn't reflect or doesn't show you the text that is actually in it. We talked about how to use the notifier. We talked about how to use a list picker and a list view. Okay. I didn't use a spinner too much. Okay. But when you look at the help file or the help information of a spinner component displays a pop-up with a list of elements. These elements can be set in the designer or block editor by setting the elements from string property to a string separated concatenation, or by setting the elements property to a list in the blocks editor. So in that regard, it is pretty much the same thing as a list view. Okay. So it's how you interact with a spinner that is different. So a spinner normally does not take up a lot of screen space. It's just a little box. But when you click on it, it will expand. It's a drop-down box, basically, that allows you to select one of the options. So it's kind of like a list view, except it's usually tucked away and not use up a lot of screen space. So from that perspective, it's not really that different. All right, so that we talked about labels. Okay, they're fairly simple items to talk about. Image, kind of the same thing. It's just for display purposes. So on this list here, are there any questions about the user interface components? Any particular one here that you think, okay, can we talk about this a little bit more, or a particular aspect that we want to talk about a little more? These are all user interface, interaction type of components. Yep, go ahead.
When you have a list of things from like I have a name, a phone number, and a date. That's my list. Is it better to use a list picker to allow the user to be able to select which one they want, or the list view? Because you were selecting a list view item in one of your applications.
Well, the difference between a list picker and a list view is, I think in both cases, you get to see the entire list at all time. No, I take it back. Actually, I take it back. In the list picker, it is also collapsed normally. So it's only when you click on the list picker that it will show you the items that you can choose from. But a list view, on the other hand, is displaying all the options unless you need to scroll. But it does show you all the options all the time. So a list view is helpful when you need to, like constantly refer to, okay, what choices do I have, and then you pick one. A list picker is more useful when you have other things on the screen and you don't want your list picker to take up too much space. A spinner is kind of like a list picker because it's collapsed normally. It's only when you click on it that it will display the options. Any other questions about any one of these? We talked about sliders, okay? I'm not sure whether you guys remember how to use a slider. A slider has certain properties. It allows you to change the start value, the end value, and then depending on where the thumbnail is, it will reflect its current value. So it does all the scaling for you, and you don't have to worry about doing all the scaling. And you can control the displayed width, so you can make it as wide as you need to make it easier to pick one item out or pick a particular value out of the whole thing. Any other questions about these particular items? And these are the ones that have a lot of a lot of event handlers, because they're all user interface elements. So each one has a way, well, most of them, because a label doesn't have anything. Okay, if you put a label into an application and go to the blocks, and then you say, okay, what can I do with a label? Okay, so let's pick a label here. And you can see a label has no event handler because you cannot generate an event with a label. Now in Java, using Android Studio, a label is still what we call a window, which means you can press on the screen where a label is, and it will still say, oh, somebody is just clicked on me. So a label in an actual app is not quite the same as what we have here. You can still quote unquote interact with the label because you can still intercept touch events and stuff like that. But in App Inventor, they makes it simpler so that we don't have any type of user interaction ability with labels. So I think there may not be any additional questions about the user interface components. If not, we can go to layout. And if you guys still remember, I'm pretty sure most of you still remember because I know many of your apps make use of layout in order to control the placement of your buttons, your labels and whatnot. So these are mostly really just for containment and arrangement purposes. Depending on whether you want to put multiple things on the same row, which is the horizontal arrangement, or put multiple things vertically, which is the vertical arrangement, or you want to put things into a grid, which is the table arrangement. But one advantage of using layout or using these so-called arrangements is you can treat the entire arrangement as one thing. In other words, when you want to hide multiple items, you can just hide the entire arrangement. Then everything within the arrangement becomes invisible. So that's one kind of nifty way of using layout, is to group items together. So you have one single property, which is the show property of the entire arrangement, and you can control multiple items at the same time. So it's kind of handy from that perspective. In this class, we don't use media a whole lot. Most of these, if you use it in your app or in your own project, that's cool. This one is new. I haven't seen this one before. Yandex Translate. Has anyone used this one or aware of this? It's new to me. Text-to-speech has been around for some time. So between text-to-speech and speech recognizer, you basically have access to be able to talk to your app and have your app to talk back to you. So I think these two are kind of significant, in terms of what they can do with your app, especially with accessibility. The rest, I don't think we have any particular questions about the rest. In the final exam, I'm not going to introduce anything that we have not used in the class. So if we have not talked about, let's say, the text-to-speech feature, it's not going to be in the final exam. We talked about drawing and animation, which only has 3 particular items because you have the canvas, and then within the canvas you can use a ball sprite or you can use an image sprite. A sprite is basically something that has a programmable velocity, so it can update its location automatically. But the best thing about using sprites is when 2 sprites collide, it generates an event. So this way you can write simple games by using one as a tank and the other one as the projectile. So when the projectile hits a tank, it generates an event. So your game can say, oh, okay, now we have to handle the collision of a shell and a tank. Display the explosion. Increase the counter, the score by 1 and stuff like that. So that's why these things are useful. But the bad thing about the canvas is you cannot integrate any other items other than sprites inside the canvas. And it's also very limiting in terms of how you can draw text inside the canvas. In other words, once you draw text, it doesn't even tell you how much space that text is using, which is not very helpful. Because if you draw the text and it tells you the rectangle that contains the text that you have just drawn, you can remember that and then you can implement your own buttons. But since it doesn't tell you that, there's no way you can actually do it. So that's why Canvas, as far as I'm concerned, is really only good for certain games and certain types of user interaction where it is free form, because you can handle drag, swipe, and stuff like that within a canvas. So it has limited application. It does allow certain types of user interaction that we cannot do with the other user interface components, but the application is still kind of limited. Sensors is definitely some of the fun stuff. We have talked about clock quite extensively. Okay, so clock will most likely be in the final exam. So you might want to review what a clock can do. We haven't really done anything with barcode scanner, so that's not going to be in the exam. Accelerometer is useful. Okay, if you want to do a pedometer, if you want to do a level application, that's what you want to use. But since we haven't really done anything with it in class, so that's not going to be in the final exam either. Gyroscope, we haven't done anything with it. Location sensor, I actually wrote a really simple app to say, okay, if the location has changed, tell me what is the current address. It works. Okay, it took about 3 minutes or so for it to acquire the current location, but the text for the current address is updated correctly. It showed 4700 College Oak Drive, Sacramento. So so I know for sure that it does work. Many of these you cannot really test unless you are running on an actual device. Clock is pretty much the only one that you can test without being on an actual device. In a certain way, the orientation sensor you can test as well, because you can actually rotate the emulator using certain hotkeys. But the rest is really hard to test without an actual device. And that's why we did not talk about most of these. Social, we haven't really talked about these extensively, so none of these will be included in the final exam. They are basically ways for you to contact, or for your app to contact other devices. And I think texting is a particularly interesting one, because you can make your app intercept all the text incoming as well. So that makes for some interesting apps. Sharing is just popping up the sharing. For those of you who have not looked into this one. Okay, so the description here is just it's a non-visible component that allows the sharing of files and/or messages between your app and other apps installed on the device. It allows your app to specify something, and you can say, okay, I have this file that you have generated or you have created within your app, and then you can use this component so that the end user can choose, oh, I want to send this file to my friends using Gmail, using any one of the items that you normally see when you click share with any type of apps. So it's kind of handy for that purpose. Okay, so we didn't really do much with social in this class. We did talk about a few of these items. Okay, file is kind of important. TinyDB is definitely important. So these two particular items we have talked about, and I have sample programs to utilize these particular things. Now when you look at file, okay, this is a little bit misleading because the file component is not actually a file. It is an interface to utilize a file. Let me show the information here. So when you look at the help for a file, okay, I'm just going to read out the entire thing here. Okay, it just doesn't lend itself to wrap around because I think they have some big image within this HTML document. It's a non-visible component for storing and retrieving files. In other words, this is an interface to deal with a file, to deal with an actual file. So right here it says, use this component to write or read files on your device. The default behavior is to write files to the private data directory associated with your app. The companion write files to a different place, so depending on whether you're developing or whether you're distributing your APK file, it can behave differently. So that's what the file is. Are there any questions about the file component? TinyDB, we have used it quite a bit. Okay, so I'm hoping that you guys still remember how to use TinyDB. It's really just a tag and a value. So you can say, okay, retrieve the value associated with this tag, and it will go to the TinyDB, which is non-volatile, which means when you turn off the device, it will still be there. Okay, you can also store values associated with the tag. So those two are the primary ways of using TinyDB. But TinyDB can also give you a list of all the tags that are already in the TinyDB, so you can actually enumerate and retrieve everything in TinyDB, which can come in handy if you want to say, okay, I have an app that usually stores everything locally within the drive, but occasionally you want to back up everything into cloud storage. So what you can do is you go through TinyDB, go through every single item, create a list, okay, one big thing, use JSON encode so it becomes just one long text string. Then you can use share and use whatever method you want to use to back up your file, not the file, to back up that string. Okay, so it is kind of useful from that sense because you can use so you can back up your entire TinyDB or retrieve an entire TinyDB remotely from the cloud by reversing that process. Is that okay so far? Okay. So for those of you who want to extend your app beyond this class, after the end of this class, you still want to kind of work on your app and say, I want to make it better, I want it to be able to back up stuff. This is one way to use TinyDB, is to go through all the tags, form one huge JSON list, and then use share to upload it to Google Drive or whatever is available on your phone. Because the list of ways to share depends on what you have installed on your phone. So on mine, I can share using WeChat because I have WeChat also installed. So it depends on what type of app you have installed. If you have Facebook installed, you can share with Facebook. We talked a little bit about TinyWebDB. I personally would not use it because it's not secure for one thing. And then with connectivity, the most important one that I have talked about is the web component. it allows your application to be able to send out URLs and get a web page back without using a web viewer. So what you need to do is to remember a web viewer is a visible component, but it can also run JavaScript. A web component, on the other hand, is a non-visible component, and its only job is to act as an interface so they can form queries and send it out to a remote server and get a reply back. So that's the major difference between a web and a web viewer component. Those two serve entirely different purposes. I didn't have a chance to show you guys Lego Mindstorms. I wish I had the time to do it. Because with Lego Mindstorms, or at least with the NXT version of Lego Mindstorms, which is like the previous version to the current one, you can actually have your cell phone to control, using Bluetooth, the NXT controller. So each one of these is a particular block that controls a particular thing or sends a particular thing. So with Drive, okay, I'll just click on one to show you what you can do with this one. It's really cool, you know, okay, it doesn't want to show the text or the help here. Okay. Is it because the web, no, okay, it's just that they don't have the help here. But you can go to the website and actually find out how to use these blocks. I had an app that programmed a robot implemented using the NXT kit from Lego Mindstorms, and it would sense, you know, something. It's basically, the robot itself is nothing more than a dumb terminal. The actual intelligence is on the phone. So I'm using the phone to remotely control the my Lego drone, okay, so to speak, to avoid, you know, obstacles and, you know, navigate and do all kinds of other stuff. So it's kind of interesting, you know, for those of you who have, you know, kids or know people who want to play with robotics. App Inventor, interestingly, actually can hook up to robotics through Lego Mindstorms. That actually brings me back to one more thing. You know, depending on what you want to do, this is definitely some kind of advanced little feature. Is you can also use a Bluetooth client and Bluetooth server blocks here to make your cell phone interact with just about anything Bluetooth. That would include Bluetooth GPS devices, so you have an external device that's Bluetooth enabled. It would also include just about anything that's Bluetooth enabled. You can remotely access it using your app. Now that really opens up a lot of possibilities, especially for entrepreneurs or inventors, because, you know, electronics is cheap, okay? You can actually do stuff with electronics using Arduino, what is the other one? It's the Raspberry Pi and stuff like that. And all of those, you know, have components, they all have Bluetooth components. So by combining the Bluetooth ability of App Inventor and the Bluetooth device on the other side, if you program both ends, now you can have your app to act as a dumb terminal to control something on the other side through Bluetooth. And Bluetooth, for the most part, is just a serial stream. So if you know how to process text, okay, both as input and output, you know how to deal with the other device. Especially when the protocol is up to you to decide, then you just have to implement the protocol on both sides. So this is, you know, one potential ability of App Inventor. That has a, you know, it just expands what you can do with App Inventor quite significantly. All right, so are there any questions about, you know, these components? I'm not going to ask you any questions, or the final is not going to be involving Lego Mindstorms or Bluetooth, but with the ones that we have talked about, are there any questions? Mostly just user interaction components, okay, with the exception of the clock, because we did talk about the clock quite a bit. Okay. Now the activity starter looks like a kind of, okay, we don't know what it is and it doesn't seem important. It is actually kind of important, because an activity starter is how you can start up other applications on your phone. So if you want to start up, let's say, you know, Google Maps, okay, you can use activity starter from your application to start up Google Maps. And if you know how to pass the information into Google Maps, you can make a Google app to look up a particular location or a particular address that you specify in your own app. So it can potentially be useful, okay? For instance, in certain cases, okay, background is not here, but if he was here, in his app, you know, he allows people to request services like snow shoveling and stuff like that. So with Google Maps, you know, if you are the one answering a particular request and say, yes, I am available, I have a snow thrower, and I want to make a few bucks, then you can say, okay, I accept this job, and if everything goes through, then your app can start up Google Maps and say, okay, so this is how you get to that place. So there's a lot of potential, you know, with Activity Starter, because now we can count on other applications on the phone or the device to do additional stuff on top of what your app is doing. So that's it's kind of useful. Okay, so with all of these components, you know, kind of explained, what we'll do next is to go into blocks, because there are important blocks that we do want to understand in this class, because we have talked about these quite a bit. So within the built-in ones, we'll start with control. And let's just take a look at all the blocks within control and see which ones we have talked about in this class, and also what they do. We have used the if-then block quite a bit. And since CISP300 is a co-requisite of this class, so I'm assuming everybody should now know what is a conditional statement, or in this case, a conditional block. It allows you to branch or select a branch out of multiple branches based on conditions. And what happens is you can make a block. Oh, okay. This is a prime example of the cumbersome aspect of graphical programming, because I have to find a place to put it. And sometimes my block, like this one here, is super long, and I can't get to the end unless I scroll like multiple times. So that's certainly inconvenient. But using this button here, you can select, you know, you can add additional else if blocks, or you can just add an else block. An else if just allows you to test multiple conditions to select a particular branch. But the sequence of testing is going to be from top to bottom. So the first condition that comes true, the branch of that condition will execute, and nothing else within the conditional statement would execute in that case. So that's the conditional block. We talked about loops as well. So let's pick the loop that we talked about in this class. Okay, I'm going to zoom out a little bit just so that I can see the scroll bar without having to scroll horizontally. So we talked about the for each block, okay, but this one only applies to a list. So the notch on the right hand side, this one over here, it has to connect to a list. But this gives you a very convenient mechanism to go through every single item in a list. And you don't need anything else to do that. So you don't need to keep track of a counter of, oh, which item in the list am I looking at, because it just basically goes through each item in a list, and then you can specify in a do block here, you can specify what do you want to do with that item. The only thing, or the few things that you don't want to do with a for each block, is to delete the items in the block, okay? That can cause problems, and I would not strongly recommend not to do that. The next one is a while block. You can call this a pre-checking loop. You can call this a while loop. You know, it just depends on, you know, what is your exposure. But it's basically the same thing. We test a condition first. If the condition is true, we perform one iteration. Then we go back and test the condition again. So in other words, we're testing, doing until the test fails. Until the condition of the test gives me a false, then you get out of this block and continue with whatever is after that. So a while block is the most general loop you can make, because, you know, if you want to go through a list, you are responsible to keep track of the index of the item that you're dealing with in the list. But because of that, you can also do all kinds of operations. For instance, if you want to search and find a particular item in a list, you can do it with a for each, okay? But in the for each, it won't stop. Okay, if you go through a list and say, oh, this is the one that I want, it's not going to stop. It will go through the entire list. Now you can use a variable and say, yes, I have found what I'm searching for, but the loop will keep going. Okay, so it's just going to be chewing up extra time. But if you use a while test, the next block here, oops, I just clicked it, but that's okay. If you use this one, then you can say, as soon as I find a match, get out of the list, get out of the loop. So it leaves a lot more on your to become your responsibility, but at the same time, it is also a lot more general, so you can do all kinds of stuff that the for each block cannot do. All right, so I'm going to toss this away because I don't really need it in this particular program. I'm just showing you what you can do with all these control stuff. This is an if-then-else block, which seems kind of like the other one, except you can see there's a little tab on the left-hand side. So what that means is, based on a condition which is next to the if, you can have the entire block to return one of the two values. So you can specify the then value, or you can specify the else value. If you know C and C++ already, this is called a ternary operator, where you can have a condition, a true value, and a false value. It's basically the same thing. You do not necessarily need to do this. You can actually do this block with the other types of blocks. It's just a convenient feature. And then this next one is do result. Okay, the do result block allows you to specify two subblocks. The first subblock goes to the top here, which is going to be a whole bunch of actions, and then the result block has to specify a value. So this entire block gives you the ability to specify a bunch of actions, stuff that you need to do, and then at the end of all the actions, you get to specify a result, so that this whole thing can connect to anything that expects a value, even a comparison. Okay. In other words, let me just kind of illustrate what I mean by that. So you pick up this block here and go to math and do a comparison, like this one here. And given that the result that you will end up with is a mathematical value, you can do this. This is not something that is easily done with other programming languages. Most other programming languages does not have a feature like this. Now the downside of doing something like this is if your do block is really long, really huge, then your comparison block will be enclosing that. So that means that the comparison block, the blue one, is going to be huge as well, which makes it kind of hard to read because the equal to or the comparison operator is at the top of the whole thing. So yes, we can do all kinds of cool stuff with this, but do you want to utilize that feature? Well, it depends. Okay, for simple stuff, if your do block only has one or two things to do, fine. Okay, but if it has like another loop, inside there's a conditional statement, inside there's a for each and stuff like that, may not be a good idea to do something like this. Just because we can doesn't mean it is a good idea. Okay. So once again, we'll throw this away into the trash can, and I need to find it first. There we go. Toss it away. And going back to the control blocks. For each number, I don't think we talked about this one, but it's basically the good old for loop in BASIC. So in this case, it would go from 1 to 5 with a step of 1, which means number as a local variable is going to have the values 1 for the first iteration, the value 2 for the second iteration, the value 3 for the third iteration, and so on. So it's a very limited kind of block. If you know ahead of time that you have to do something X many times, this is great for that. But once again, it is not general. It's not nearly as general as the while block. So it has some applications. I personally do not use these much. We talked about it for each block already, so we'll go ahead and skip that one. We talked about the while loop. We talked about the do result. Evaluate but ignore result. It sounds really kind of, it doesn't sound like it's useful, but if you have something that will do the computation and it has some kind of side effect, this is useful. So you're ignoring the value of the operation, but you are keeping the side effect of those operations. Okay. These two are particularly useful. I'm certain that we talked about these two already quite a few times. Open another screen. This is the way for you to open another screen of the same application. If you want to open the screen of another application, you will need the activity starter. Okay. So the first one, which is just open another screen with a screen name, allows you to open another screen, but without passing any information to the other screen. So if the two screens do not need to communicate, then you can use the first one. On the other hand, if your other screen can use a start value, then you need to use this one to specify a start value. The start value can be any value, which means it can be a numerical value, it can be a string like a name or an address, or it can be a list. Now, once it can be a list, then you can embed all kinds of stuff inside it. Okay? So the second option, which is open another screen with start value, is a very general purpose way to open up another screen, and it allows you to pass information to the other screen, the one that you're starting. And it doesn't serve you any purpose if the other screen has no way to get to the start value. So this block here just gives you the ability to get the start value of a particular screen. What about screen 1? Do you think screen 1 has its own start value? Remember, yep, screen 1 does have its own start value, which means if another app starts your app, the other app can give you a start value to screen 1. So that's how you can start the whole app, knowing what you need to do, even with screen 1. Okay, so remember, screen 1 is just like any other screen from the perspective of a start value. Screen 1 can have a start value. And then we have the two closed screen blocks, basically corresponding to the two open. One is just to close the screen without any type of value to pass back to whoever started the screen, and the other one will close the screen with a value so it can specify a result. So open the screen is like calling a subroutine, closing the screen is like returning from a subroutine. In both cases, with open screen, you can have quote-unquote parameters by using the start value. When you close the screen, you can have a return value in quotes by using the result. Okay? So these are particularly useful when you have a multi-screen application and you have information to pass from one screen to another screen. Closed application is just closing the entire application. I typically do not like to use closed application because it is abrupt. Okay, it just closes the entire application and it doesn't give you a chance to close with a value. Okay, so that's not it's not flexible. I would not choose and use these two blocks. Get plain text, get plain start text and close screen with plain text because value is far more flexible compared to text. So I personally would not use these two. It says right here, when you might want to use it is when you are closing your application and you think you're started by another application, so they may not know how to do with a list. So in that case, using plain text is appropriate. Okay, we talked about logic. There's really not a whole lot to talk about logic here. Logic allows you to specify two constants, one is true and one is false. There's a unary operator, which means it only got one operand or one thing to operate on, is negation. And then we have the two logical connection, which is and and or. And then we have the comparison to compare truth values. So it is only either equal to or not equal to, but they can only be true, false values, cannot be anything else. So I'm going to toss this away. There we go. The math blocks, we talked about a few of these, but not every single one. This is a constant. This is comparison with numerical value. Now, it is important to differentiate, are we comparing strings or are we comparing numbers? Because you can do both. Now, App Inventor, unlike in Java, is not typed, which means a particular variable can be seen as a numerical value on one hand, and it can also be seen as a text on the other hand. There's no differentiation. You cannot say oh, this variable is string or this variable is a number. It is both at the same time. So how do you control the way you compare? You have to choose the right comparison. So with the green block, with the blue block here, it is comparing as if it is a number. But if you choose the red block here, then it will compare as if it is text. What is the difference? The difference is if you compare, let's say 100, which typically we interpret as 100, with 99, which we usually interpret as 99, okay? If you use the blue comparison, the 100 is considered greater than the 99, which makes perfect sense, right? But you can also use the you can also use the red comparison, which will then be comparing using text comparison standard. But when you use text comparison standard, 1 is less than 9, so 100 as a string is less than 99 as a string. So that's when you have to be careful about, okay, how do I want to compare these two variables? Because do you want to see these things as numbers, or do you want to see these things as strings? Okay. I don't think we have to talk too much about addition or multiplication or subtraction or division. This is to the power of, okay, so you can raise the power of something. We talked about random numbers because in one of our apps we have to start at a random location, or we have to start with a random heading of that sprite. So we talked about this one. Random fraction is just a random number between 0 and 1. If you don't set the seed of a random number, your app may end up going through the same sequence of random numbers. So setting a random seed allows you to truly randomize your random numbers, and you can set the seed to some really unlikely to be uniform type of number, like the current time in milliseconds. Okay, so that's a pretty good seed to use. We haven't really talked about much of the other ones, okay, to find the minimum, square root, the absolute value, the negation, rounding, okay, which is if it's more than or equal to 0.5, you round up. If it's less than 0.5, you round down. Ceiling and floor, okay, it doesn't give you the definition, but the ceiling of a number is the smallest value that is the smallest integer that is greater than or equal to whatever number you have on this notch here, and the floor is the other way around, which is the smallest number that is, no, I take it back. The floor is the largest number that is less than or equal to the number on the right-hand side. Okay, is that okay or not? I don't think we need to use these, okay, in this class, so I'm not too concerned about it. Modulo of is the remainder of in the division. So let's say you have 5 divided by 3, then the modulo is going to be 2. Then you have the usual trig stuff, sine, cosine, tangent, arctangent. You can convert units from radian to degrees. This allows you to format a number. It returns a string that is formatted correctly. This allows you to check whether something can be interpreted as a number. So you might want to check this first before actually doing some math on a variable, just in case it is not a number. And this allows you to convert base for display purposes. So are there any questions about the math blocks? The questions? Text blocks, we haven't really used a whole lot of the text blocks. We use the literal constant. I'm pretty sure we talked about that. We talked about the join operation, which allows you to concatenate multiple strings into one big string. Length is just telling you the number of characters of a string. Okay, this allows you to test whether a string is empty or not. Okay, this is for comparing strings. String we haven't really talked about. It's just for removing leading and ending spaces. So it's good for validation. Before you validate something, you might want to just get rid of all the beginning and all the ending spaces. This one allows you to convert everything to uppercase or lowercase. Okay, because it's a drop-down box, it does allow you to select lowercase. The other ones allow you to. It returns the starting index of the piece in the text. And it basically allows you to search for a fragment inside a particular string. And it returns the position of the fragment in the string. In C and C++, this one is known as stir or string. It looks for a string within a string. This one, it tests whether a piece is contained in the text. So these two are closely related, where this one returns the index of the piece in the text. This one just confirms either it is true or false, whether it is there or not. You can split text at a particular place, so this will give you two text as the result. And you can also split as spaces. Now this one is interesting because you can give it a single text that has multiple items separated by spaces. And the result of this, it doesn't say specifically here, what do you think it is going to give you back? A list, exactly. A list of all the pieces that are separated by spaces. Okay, very good. This one is kind of general purpose. It allows you to specify a particular segment within a string. You specify where do you want to start and how long is the fragment inside the text here. So it allows you to extract any subcomponent of a text string. This one allows you to do replacement. Unfortunately, it doesn't deal with regular expression. Otherwise, it would be kind of helpful, but it does not do that. And obfuscated allows you to obfuscate text. It produces text like a text block. The difference is the text is not easily discoverable by examining the app's APK. Use this when creating apps to distribute that includes confidential information like keys and whatnot. This provides only very low security against expert adversaries. So in other words, it is kind of useless. All right, we have done a lot of stuff with lists, in case you do not remember. So a lot of these blocks we have used, or I have used in the procedures that I have written. Create an empty list, make a list. I don't think we have to explain those. Adding items, always add to the end of a list, is also appending, basically. This allows you to test whether something is in a list or not. I have not used this one much because it only applies when what you are searching for matches one of the things inside the list. And it has very limited application. This one is useful. It tells you how many items are in the list. So if you want to use a while loop to go through a list, you need to compare to the end of the list, and this is how you can tell which item am I dealing with in the list. Is this the last item? This allows you to test whether a list is empty. It's kind of a shorthand because if you know the length of a list, you can test that. If the length of a list is 0, it is an empty list. So is list empty is really a shorthand, is an abbreviation, a convenience, because it can be done using other blocks. Pick a random item in the list. Once again, this is a convenience because we have random numbers already. So combining what you can do with random numbers and knowing the end of a list by using the length of a list, you can implement this block by using the other blocks. It's just a convenience feature. This one is kind of the same thing as is in list, except it is not giving you true or false. It is giving you the actual position of the thing in a list. And if I interpret this correctly, thing has to be text, cannot be anything else. Select list item. This is really useful. I use it quite a bit in my code. It allows you to specify a particular item in a list based on the index of that item in the list. It will just give you back whatever it is. So if it is a list, a sublist inside the list, it will give you the sublist. Insert allows you to specify where do you want to add an extra item to a list, as opposed to add to a list, which is always adding to the end of a list. So it means this one is more general. Okay, you can do the add to list using this item because you always know the length of the entire list, which means you can implement appending using this particular block. Once again, the other one is a convenience feature, so you don't have to do all the complicated stuff. Replacement, you just say, okay, I want to replace a particular item in the list with its replacement. You can remove a particular item in the list. So these things that can change the list itself, it is not a good idea to use these inside a for each block. Okay, because the for each block, as the name implies, says, I want to give you every single item in the list, and for each item you can specify a particular action. But if you're changing the list on the fly while you're going through that, I do not know what it's going to do with the extra item. Okay, will it go through the extra item that you're introducing into the list? Maybe, maybe not. Okay, so as a general idea, do not use any one of these blocks that can change the list inside the for each block. Okay, it's just not a good idea. Append to list, this allows you to combine two lists into one. So it will append all the elements of list 2 into list 1. But it doesn't return anything because the result is a changed list 1. This one allows you to replicate or clone a list. And remember, if you don't clone a list and you have two variables, each one is a list, or you set one global variable to another global variable and they're referring to the same list, if you change the list through any one of these two variables, the other one will change as well. Okay, so that's one kind of tricky thing that you have to remember when you're manipulating lists. This allows you to test whether a particular thing is a list or not before you start to use list-specific operations on that thing. And then we have a whole bunch of conversion subroutines here, or conversion blocks. For the most part, I don't really use these because CSV is useful, but it is not nearly as flexible as JSON encoding. So if you have the capability to do JSON encoding, I won't even bother with CSV unless whatever you're talking to only understands CSV. Then these blocks become useful. So you can convert to, convert from. This one is really useful. It turns out to be the last block of this particular category. It allows you to treat a list as a list of key value pairs. Then you can supply the key and say, hey, I want to find the value corresponding to this particular key, which is the same concept as a tag in a TinyDB. Okay, so this is really kind of useful because it doesn't matter how you order the key value pairs because it's done by matching the name of a pair and not by the position. Okay. All right, so that's all the lists. We did a little bit about the colors, particularly we used some of these predetermined colors, and we also talked about how to make a new color by combining these three numbers. So you can combine RGB to make a new color. You can also split an existing color into its components, which is going to be a list of 4 items because it's RGB and alpha in this case. Alpha is the transparency. And the variables, typical stuff, for the most part we use global variables. We use the get to refer to a variable. We use the set to change a particular variable. And then we have these 2 blocks here that allows you to specify local variables. One is just a block that will do something. The other one is one that it returns a particular value. That's the only difference between these 2 blocks. And then we talked about procedures. Okay, we talked about how you can extract some code into a procedure. So this way you can invoke or call a block, call this procedure, instead of replicating the code all over the place. So it's really good for organization purposes. Okay, so are there any questions about all of these categories? Any one of these you want me to go back and re-examine? Okay. So in the final exam, I'm not going to out of the blue and say, oh, let's try out something that we haven't done before. For instance, let's go here and specify extracting a segment out of a particular address. Okay, I'm not going to do that. Okay, but stuff that we have done already, like join, we have done already, comparison, we have done already. Those you have to be familiar enough to understand what a block does and how to use a block in your own code. Okay. So are there any questions about the scope of what blocks will be involved, what you should understand, and be prepared for the exam? Now we talked about this a little bit earlier. So what I would do is to make the program that you have to understand available before the final exam. Okay. So for the purpose of just knowing when, I would just say 24 hours. So 24 hours prior to the final exam, I will give you guys the actual AIA file that you'll be working on, but I won't tell you what you're supposed to work on. So what you can do is to get the AIA file, read it, understand it, comment, and just understand the whole thing. And then by the time you get to the exam, which is 24 hours after I make that file available, then I will tell you what you're supposed to do with the program, how I want you to modify the program to extend the features and whatnot. Okay, so that will give you 24 hours to understand the existing code. Okay, now I'm not going to ask you guys to write something that's complicated, like recursive subroutine to go through a list, find all the stuff. Okay, you're not going to write it, but if I give you a procedure like that, you will still be able to, you're still expected to understand the code that I have written. So that 24 hours will give you some time to comment and document all the stuff in the application itself. So by the time you get the instruction of what you need to do, you already know, you have already mapped out the program. And you say, oh, okay, I know exactly what to change and how to change it. So that's kind of the arrangement that I want to give you guys. Is there any objection to this arrangement? Okay, it's good. Okay, all right. And for the purpose of the final exam, if you guys want to kind of sit down together to study the program that I give you like 24 hours prior, it's okay. Okay, I will let you guys do that, to study together, to look at the program together. But in the final exam, when it's time to actually change the program, it will still be individual work. Okay, so just want to make that clear so that you guys can say, oh, okay, let's sit down together and take a look at this program together. That's okay, not a problem. But when it's time to actually change the program, it will still be individual. All right, so I think I have gone through all of the stuff that you need to know for the final exam. Are there any questions that you need to ask regarding the App Inventor or anything related to your project?
Actually, I do have a question.
Go ahead.
My app is basically the pedometer with the dog and so on and so forth, but I was trying to make it so that the user could make their name by popping up a notifier so that they could enter their name. So
Okay.
I chose the show text dialog.
Okay.
The one that's confusing me is for component. What value
Okay.
would that be?
All right, so the question is how to use the notifier to enter a name and be able to utilize that name in your application.
Yeah.
Okay, so let's go ahead and just write down something like that. So we'll start a new project and say ask for name. And for the purpose of this one, I'm going to have a label to reflect the name and a button to trigger the dialog, to trigger the notifier to do something. So these two are just really basic stuff. And on top of these two, obviously I need a notifier. So we'll drag a notifier in as an invisible component down here. All right, so in the blocks, I am going to have one single thing to trigger the entire operation, which is the clicking of the button. So when the button is clicked, I am going to use the notifier to do something. So we click on notifier, and we have to look at all these blocks and find out, okay, which one is applicable here. Now, after choosing or after text input is going to be useful, but I'm not going to do it just now, okay, just yet. I just want to trigger the notifier to ask the question, to ask the end user to input something. Dismiss progress dialog probably is not useful. Log, not useful. Log info, not useful. So we keep going and going until we get to, I think this one, show text dialog,
Yeah.
shows a dialog box where the user can enter text, after which the after text input event will be raised. If cancelable is true, there will be an additional cancel button. When you click the cancel button, it will specify cancel in the event handler. Entering text will raise the after text input event. The response parameter to after text input will be the text that was entered, or cancel if the cancel button was pressed. So this is the block that I want to trigger the notifier to display something for the end user to type in something. So it has two particular items or two notches here. One is the message, one is the title. The title is the text that goes to the top of the notifier, and then the message can be a little bit longer because it's the body of the notifier. Okay, so we'll go ahead and specify some text strings here. And I'm going to specify this as not cancelable, so people cannot back out of this. Or, well, let's make it cancelable. So this way I can show you how to process what if somebody says cancel, I don't want to do anything.
Okay, that's helpful.
All right, so the message can be the longer part, and you can say, enter the name of the person walking the dog, or something like that. Okay, it can be long, can be lengthy. The title, because it has to fit in within the title bar, it has to be simpler. So you just say, enter information, or something like that. It's just a title bar. All right, so this will basically, when this block executes, it's going to pop up a notifier on the screen with the title and the message and an empty area for somebody to type in the name. Okay. So what you need is, okay, we can test this right now. Okay, we'll go ahead, just go ahead and test it. And let's see.
Can the name be entered be passed by value to like another screen, or does it have to go into a dialog box on that screen and then passed?
Well, let me get this working first, and then we'll test it. Okay. All right, so that's up, and now we can start the emulator. Okay. Okay, so let me get back to your question. So the only way to get the text that the user has entered is to use the event handler of after text input.
After text input, yeah, I got that.
Right. So what you do within that block is entirely up to you.
So if I put close screen with value result,
You can do that.
and it'll just it'll pass through.
It will pass that text along as the result value to whatever screen starts this particular screen.
And then on that screen have if other screen closes. Okay.
Yep. So that's if you want to do it that way, that certainly is one way to do it. But typically, if you do something like that, you might as well just use a text box within this screen, and then you allow a button to say save name. When they click save name, it will close the screen. It's just from the user's perspective. If you use a notifier, most people do not expect the screen itself to close after confirming something in the notifier.
True.
But that's a user experience issue, and it's not a technical issue. Okay. All right. So now we have the app up and running. So when I click the button, it will pop up the dialog box or notifier box, and I can just type the name here. Okay, say tag, and press the enter key. Oh, it's a multi-line thing, so I have to go to close this, and then click OK. Okay. So if I want that to display, in the label, I need to finish this program by intercepting the after text input event handler, which is within the notifier. So we just pick this block here, and then we just deal with the response. Now remember, if I click cancel, then the text cancel is going to be the response. So if I don't want to display cancel as the label, then I need to test it first. So I need to go to control and say if then, okay? So I have to say if then else in this case. Well, I don't really have to. If then is fine. I use text comparison and specify it not equal to. Oh, doesn't have that. Okay, we can tweak that. Just put a not in between and the equal here. So we want to compare the response to cancel, and I think it said all uppercase.
Just with a capital C.
Just, oh, okay.
The rest is lowercase.
Okay, the rest are lowercase like that. So we say if it is not cancel, then we want to reflect that name as the text of the label. So we go to label 1 and set the text property of label 1 to response, like so. And that should be it. Okay, so we'll give it a try. Go back to the simulator, click the button, enter something, and that should work. Press OK, and you can see how my name is updated here. On the other hand, if I go to this dialog box and just click cancel, then it doesn't change it. It doesn't say cancel as the name.
Okay.
So that's how you can test whether the end user clicked cancel or not. Is that okay?
Yep.
Okay. Any other questions? Any other things that you want to ask about your project? Any obstacles? Nothing? Your apps are pretty much up and running? Okay. All right. Well, it is the end of the lecture time, so I'm going to take a 10-minute break. So when I come back, it's the lab time. So if you have anything to show me, anything that you say, okay, I'm not really quite sure how to do this, that would be a good time to do it. It doesn't have to be limited to your own project. If you see one of my earlier programs and you say, I don't understand how you did this, can you explain this code? That's also something I can do during the lab time. So meanwhile, I'm going to take a 10-minute break to have some coffee, and then we'll start the lab time.